Okay, excuse me, 2.15, the Pythagorean theorem. We all know what the Pythagorean theorem is. It actually started out as, and was founded by finding the areas of the length sides of triangles and, or in this case, rectangles. Then you put in the diagonal, and of course you get the right triangle. So the formula for Pythagorean theorem, so we get a squared plus b squared equals c squared, where a and b are the legs of the right triangle and c is the hypotenuse. I actually like and prefer that this formula be used rather than A, B, and C. But that's up to you. Okay. They give us an example, and we all know how to solve this. And when we use word problems, please, the first thing you have to do is draw a picture. Okay, draw a picture of the triangle, the right triangle. It takes less than a second and it will help you tremendously. Okay, so let's go ahead and they give us some like a process how to find or how to do and apply the Pythagorean theorem. This might be handy if you keep forgetting how to use the Pythagorean theorem, but I think we all know by now. We probably know by heart how to do this. Find the length of the hypotenuse of a right triangle if each leg measures 10 feet. Draw a picture. Each leg is 10 feet, 10 feet. And then this is the hypotenuse. You can call it X, Y. I'm going to call it C. So 10 squared plus A, where I'm using A squared plus B squared equals C squared. So I have 10 squared plus 10 squared equals C squared. So 10 squared is 100 plus 10 squared is 100 equals C squared. So I get 200 equals C squared. Don't forget, you have to square root both sides to solve for C. And the square root of 200 is going to be a decimal. Let's see, square root of 200, 14.14. And this is feet. Okay, that equals my hypotenuse. Now, when we take the square root of a number, we usually have to be concerned about the plus and minus. But because C is a distance, we don't have to do that. Distance can never be a negative length. Okay, B, find the length of the legs of a right triangle. If they are the same length. Here's my right triangle. They're the same length. So I could just put A squared and B squared, but we'll just make sure that we stipulate that A equals B. And the hypotenuse is 10 feet. So A squared plus, and now instead of using B squared, I'm just going to use A squared again, just to keep it so that I only have one variable to solve for. Because I know that A equals B equals C squared or 10 squared. So I just solve for A. 1A squared plus 1A squared is 2A squared. That equals 10 squared. Again, I'm going to square root, oh, I'm sorry. I got to divide by the 2 first. because I cannot I don't want to take the square root of 2. So I get a squared equals, let's see, 100 divided by 2, because 10 squared equals 100. And I'm going to divide that by 2, that's 50. I'm going to square root both sides. Don't worry about the negative. Now, in this course, I don't want to we can just do it in the calculator. We don't need the exact numbers because in actuality, square root of 50 is 5 square root of 2. But we're just going to use an approximation for this course. I'm going to take the square root of 50, and that's going to give me 7. The squiggly lines means approximation. 7.07. Okay, so either one of these is going to be a correct answer. Most of us, in fact, all of us will probably use a calculator. All right, Pythagorean had triples. Now, what this means is um, we end up with whole numbers instead of this whole decimal thing. And there are some Pythagorean triples here. The first one's easy. If I have a right triangle, it's called a 3, 4, and my hypotenuse ends up being 5. If I take 3 squared plus 4 squared equals, and if I didn't know what the hypotenuse was, they gave us 2 legs, c squared. So I have 9 plus 16 equals c squared. So 25 equals c squared. Take the square root of both sides, and I get 5 equals c. That's how I get a Pythagorean triple. 3, 4, 5. Okay. I just happen to know these because I've worked with Pythagorean triples for quite some time. So I have a 6, 8, 10. And I bet you a 9, 12. Not sure, but I'm guessing here this might be 20. Let's just work it out. 9 squared plus 12 squared equals, now you can use x squared. You can use x squared. 81 plus 144 equals x squared. Let's see, 5, 12, 225 equals x squared. Square root of 225, I think, is 15. So I could be wrong. Doesn't happen very often. 15. Look at that. Now this is 15. So we're actually adding 3, 3. This has to be 50. 3, 4, 5, 30, 40, 50. 57, 76. Let's see. 57 squared. Now we should be seeing a pattern, and it's probably not going to be too hard to figure out. Plus 76 squared equals, I got to take the square root of that, and I get 95. 60, 80, I bet you this is 100. Let's just do it. 60 squared plus 80 squared equals 10. Yep. Take the square root of 10,000 and I get 100. All I did was add zeros from the second one. All right. What relationship do you see between the first and the second Pythagorean, between the first and the third? So they want us to come up with a pattern. What relationship do you see between the first and the second? Well, between these two, they're just doubled. Between the first and the second, they're just doubled. between the first and the third. And it looks like we're multiplying everything by 3. So we're just looking for patterns. Notice that if A, B, and C is Pythagorean triple, then so is every multiple of A, B, and C that results in whole numbers. So that was the pattern. Double, I just to multiply by 2. So that's our pattern. If 5, 12, 13 is Pythagorean triple, then 2 more triples related to it. Let's see. So we're just going to multiply it by 2 and then multiply it by 3. So here's another one. 5 times 2 is 10. 12 times 2 is 24. 13 times 2 is 26. So there's a triple. Now let's multiply it by 3. 5 times 3 is 15. 12 times 3 is 36. And 13 times 3 is 39. So there's 2 more Pythagorean triples just by multiplying it by 2, then by 3. Complete the following 2 Pythagorean triples. Now we could always go back to the formula. 8 squared plus 15 squared equals c squared, or you guys are probably used to x squared. So 8 squared plus 15 squared equals 289. And I'm going to take the square root of 289, which I believe is a perfect square of 17. 14 squared plus 48 squared equals 2,500. And what is that? 25 squared. Let's try it. Square root of 2,500 is 50. Nope, 50 squared. Okay, let's see. Example 2. If Pythagorean's theorem says that if a triangle is a right triangle, then the lengths of the sides satisfies the equation leg squared plus leg squared equals hypotenuse. The converse of the statement is also true. That is, if the lengths of the sides of a triangle satisfy the equation, then the sides form a right triangle. For example, home builder is trying to square the corners of the property. A string is secured 7 inches off of the corner of the sides. The other shown as the diagram. One side is angled until the 2 marks are exactly 25 inches apart, and then a stake plan of property. Why do these measures guarantee a square corner? Because of the Pythagorean theorem. Okay. So in other words, they just have to check to make sure that the 2 sides do in fact equal the hypotenuse squared. So let's do their example word problem. Jack has instructions for building a skateboard ramp, and he needs to build a triangular frame which to nail the ramp board. A 4-foot by 8-foot piece of plywood, 4-foot by 8-foot piece of plywood, will serve as a ramp. Jack wants plywood oriented, so the ramp is as long as possible. The instructions say choose the desired height for the ramp when it is use Pythagorean theorem. Sit on the ground. He wants to end the ramp to be 2 feet off the ground. Okay, so draw a picture to get started. So let's see this. The instructions say choose the desired height for the ramp when then use Pythagorean theorem to find the length of the ramp, the frame that will sit on the ground. He wants the end of the ramp to be 2 feet off the ground. So does he want this end of the ramp to be 2 feet off the ground or this end of the ramp to be 2 feet off? I would have seen this one. So if we add the 2 feet, here's our ground. Okay. So we need to make sure, so this is going to be our 2 feet from here to here. Our 8 foot then is going to have to be here, and it has to make a right angle here. So there's our picture. This is 8 foot. Okay, so this total is 6 foot, 8 foot, and they want to know how long the bottom is. So they want this. But this is actually one of their Pythagorean triples that we just did. 6 squared plus, we'll call this b, plus b squared equals 8 squared. So 36 plus b squared is going to be 10 because that's a 6, 8, 10 triple. Oh, no, it's not. That would have to be 10 feet for that to be a Pythagorean triple. 8 squared, 64. And I subtract 36 from both sides. So b squared is going to equal 48. 3 from 5 is 2 is 28. Going to have to take the square root of both sides. So b, this leg has to be square root of 28. Square root of 28. That length has to be 5.29 feet. That's the base, bottom. And that's it for this section.